The small town of Kinzua, like many other places in Pennsylvania, was central to America's steel production. In the 1880s, demand spiked, and trainloads of coal were needed to feed the factories.
Railroad engineers faced a giant obstacle: the steep, deep Kinzua Gorge off the foothills of the Appalachian Mountains. The trains had to get through, so they set to work on one of the most ambitious construction projects of the day, the Kinzua Bridge.
Completed in 1882, at over 300 feet tall and 2,000 feet long, Kinzua Bridge was the tallest railroad bridge in the world.
At the time, this was pretty much the eighth wonder of the world. It was such an unbelievable achievement. Even with today's technology, this would be a challenge, let alone back in the 1800s. So to actually achieve a viaduct over that size gap was incredible.
Jerry Clark from the Bridge Foundation knows what made this build so epic.
Other railroads went around the Kinzua Valley. The bridge went across it and used every bit of the engineering technology available during that time.
To achieve this shorter direct route, the bridge had to be high, long, and capable of supporting heavy coal trains. Engineers ruled out the conventional bridge-making materials, stone and cast iron, instead choosing wrought iron.
Building a bridge of this size out of stone or brick would have taken forever, and using cast iron would have been too brittle, so they looked to wrought iron as a suitable material.
Wrought iron had another advantage too. It's malleable. So they used sheets of iron to create an innovative support structure known as phoenix columns.
These phoenix columns were made out of wrought iron that was folded around and held together with rivets, and this made them stronger and lighter.
The revolutionary design was also quicker and cheaper to build. However, within a decade, locomotives doubled in weight. This meant more strain on the bridge and more vibrations.
At the time, steel was the strongest, lightest, and most flexible bridge-making material around. So it sounds crazy, but they actually ripped the old Kinzua Bridge down and rebuilt it in steel.
No bridge meant no coal, so a quick construction was essential. And in just a matter of months, 120 men erected the new bridge.
90 days is all it took to completely rebuild the longest railroad bridge in existence.
The new steel bridge used the original trestle design, with large A-frames supporting the pier on top. It could now carry as much coal as the steel mills needed. But in an effort to save time, a decision was made that would turn out to be disastrous. Rather than installing new steel anchor bolts to hold the bridge in place, the legs were secured to existing bolts. They were too short, so engineers used extending nuts called collars to bridge the gap.
So replacing these anchor bolts would have taken forever. You would have needed to dig out, blast away. It would have been a real hassle. So instead, they just put these collars over the top of it.
At the time, the collars seemed a reasonable solution, but they hadn't completely factored in Mother Nature.
This quick fix did the trick, and the bridge carried freight and passenger trains for over a century without incident. In 2002, a maintenance team discovered corrosion on the bridge's legs. They closed the bridge to trains and pedestrians and began repair works. But in the summer of 2003, disaster loomed. An epic tornado spiraled towards the Kinzua Gorge. Structural engineer Brian Emberg was on the restoration team.
In July of 2003, I got a phone call, middle of the afternoon, that a tornado had hit the bridge. I jumped in my vehicle right away, made the trip, and got here right about dusk, and it was clearly a tornado scene, trees everywhere, clouds and mist, I met with the crew and made my way down here to the edge of the ravine and turned the corner, and the valley just looked filled with smoke like you would expect after a battle. You could barely start to make the structure in the fading light, and you could see pieces of steel emerging from the fog, and then what was remains of the structure still standing. It was clear it was a catastrophic failure.
The 160-kilometer-an-hour tornado had sent a huge section of the bridge crashing to the valley floor.
This must have been so frustrating. They were on to this problem. They saw it. They were acting on it. So if it struck a few months later, they would have been fine. This is such bad luck.
Although devastating to the repair team that spotted the corrosion, closing the bridge had potentially saved hundreds of lives.